Hey class, this is lesson 8.4, angles of elevation and depression. We're going to learn how to use angles of elevation and depression to solve problems. It'll also involve trigonometry. This first problem here, I'm going to offer this to you as extra credit. I'll show you what an inclinometer is. I have one in class, so you can see it. But go ahead and, if you want, you can do the vocab and check back. All right, we're going to learn how to use angles of elevation and depression. Let's quickly define that. I think that's important here. So an angle of elevation is an angle that is above a horizontal line. So usually it's from the ground, but notice there's a horizontal line, and that this person is looking up at the person in the hang glider. And the angle between that horizontal line is called the angle of elevation. An angle of depression is the angle between a horizontal line again or an angle that's below a horizontal line. So if somebody's in the hang glider and looking at the person down below, then the angle of depression is that line there. And you should know this, the angle of elevation between 2 points and the angle of the depression between 2 points are the same. And that's because of the alternate interior angles postulate. All right. So keeping that information, let's just write a description of a couple angles here as they relate to this situation. So we're looking at angle 1 now. Notice that angle 1 is between the horizontal line and the viewing of the air traffic controller. So we're going to say that angle 1 is an angle of depression from the plane to the ground. And angle 4 goes from the horizontal line here now is the ground, and so that's an angle of elevation from the ground crew to the air traffic controller. All right. Go ahead and fill in these true false quick, and then you can check back for your answer. Pause now if you want to try it. So angle 2 is an angle of elevation from the person in the hot air balloon to the bird. And that's because it's above a horizontal line. So it's actually this one here. All right, so we're going to use this angle of elevation idea to solve a couple problems here. Kyle stands 120 feet from the base of a tree, so here's Kyle out here. And if we measure 120 feet, we get to a tree. And the angle of elevation from Kyle all right, so we have Kyle looking to the top of the tree. Now normally there'd be a little bit to add here, but if we go to the top of the tree this way, it's saying there's a 40-degree angle. And we want to know the height of the tree, so let's just call that h. And this we can consider a right angle, so we can use a trigonometric ratio here. And with respect to this 45-degree angle, h is the side opposite, and 120 is the side adjacent. So that gives us the two things of the tangent ratio. So we can say that the tangent of 40 degrees is equal to side opposite, which is h, over side adjacent, which is 120. And then solving that, we can say, using the cross products property, we can say that h is equal to 120 times the tangent of 40 degrees. And we're going to get out our calculator and just do a little calculating there. And if you do 120 times the tangent of 40 degrees, and again, make sure that your calculator is in degree mode, you will find that rounded to the nearest foot, the height of the tree is about 101 feet. All right, so go ahead and see if you can fill this in. And this is a little more realistic because you are including the eye level in this problem. But go ahead and try it, and you can check back with your answer. All right, we can also use the angle of depression to solve problems and trigonometric ratios. So here we have a rescue worker. He's up in this lighthouse and spots a ship on the water at an angle of depression of 62 degrees. Remember that the angle of depression is the angle below a horizontal line. So just make a quick drawing. So let's say this is the lighthouse. And there's a person up in there looking down and spots a ship in the water. And it says that the angle of depression is 62. Well, the angle of depression is the angle below a horizontal line, so that would be right there. And the spotter is 175 feet up. So that's there. And we want to know how far away that ship is, and that would be down here. Let's call that D for distance. And so we, with respect to that, well, if the angle of depression is 62 degrees, then that means this angle down here is also 62 degrees, the angle of elevation from the ship to the person. So with respect to that angle, we have the side opposite, that's this one, and the side adjacent, that's that one, which is the tangent. So we can say that the tangent of 62 degrees is equal to 175 over D, side opposite over the side adjacent. So that means that if we want to solve that, we can say that D times the tangent of 62 degrees is equal to 175. And so D is equal to 175 divided by the tangent of 62. And we can use our calculator to go ahead and calculate that. And that is about 93 feet. All right. Oh, go ahead, you try this problem. Fill in the work, try and pick the correct ratio to use, and you can check back to see if you're right. All right, just some things that you should keep in mind here. The angle of elevation is formed above a horizontal line. The angle of depression is formed below a horizontal line. The measure of an angle of elevation is equal to the measure of the angle of depression between the same 2 points. So let's see what this person did for an error here. Homework question says that the angle of depression from the bottom of the house to a window to a ball on the ground is 20 degrees. You have to write your friend's sketch to it. Describe your friend's error. Well, remember that that an angle of depression is formed by the horizontal and the line of sight. So is that what this person did here? The correct angle of depression is adjacent to the angle identified by our friend. It's actually that one right there. So that should be 20 degrees. So our friend's error is he did not correctly identify the angle of depression. The angle always needs to be between the horizontal line and the line of sight. All right, that's the end of the lesson. See you tomorrow.